Hey guys, welcome to your second video quiz. Okay, so now we're going to evaluate the expression for the given value. So on the first one, we have 9x plus 7. That means 9 times whatever x is plus 7. And in this case, we've got that x is equal to 3. So we've got 9 times 3 plus 7. And so now we need to simplify that. We're going to do 9 times 3 first, which is 27, plus 7, and you get 34 as our answer here. Now we're going to substitute for x and for y. So I'm going to do 6 times, now remember right here, x is 6, so 6 times 6 plus 3 times 9 minus 9. And I'm going to multiply. 6 times 6 is 36. 3 times 9 is 27 minus 9. Off to the side, I'm going to do some math. So I've got 36 and 27. I'm going to add those together. 13, so I get 63 there. So I've got 63 minus 9. And then whenever I subtract those, I get 54. Alright, on this last one, I've got a squared minus b squared. So I'm going to be substituting 5 in for a and 3 in for b. So I've got 5 squared minus 3 squared. Remember, 5 squared does not mean 5 times 2, it means 5 times 5, which is 25, minus 3 squared is 9. 25 minus 9 is 16. Alright, on this section we're going to combine like terms. It's important that you understand what like terms are. Like terms mean the same variable or variables with the same exponents. And so 15x and 4x are considered like terms, so you want to add the coefficients. 15 plus 4 is 19, and don't forget your x. And that's as good as we can get with that. Now on this next one, the 6y plus 4y plus y, that's really a 1 in front of that y right there. You add your coefficients because all of those are like terms. 6y plus 4y is 10y. 10y plus 1 is 11y. Alright, the bottom left. Our like terms are 8d and 2d, and then 6 and 5. So 8d plus 2d is 10d. 6 plus 5 is 11, but you can't just leave your answer like that. You have to separate your terms with either a plus or a minus. And since that 11 is positive, I'm going to put a plus in front of it. Now 10d and 11 are not like terms. There's nothing else you can do to this. This is as good as it gets. Okay, on this last one, our like terms are 3x squared and 14x squared. And then we also have like terms of 12x and 8x. And then we have like terms of 11 and 5. So I'm going to look at the single underlines right now. 3x squared plus 14x squared gives me 17x squared. And I'm going to go ahead and just mark through those because I used them up. And then I've got 12x plus 8x is 20x. And again, mark through those because I used them. 11 plus 5 is 16. And this is as good as this thing gets. Now, I did mark through these. On my longer problems, I tend to mark through terms that I've used. On shorter problems, I don't really do that because it's not really necessary. But whenever I have a longer problem with a lot of terms, I will mark through them so that I remember that I have used them up. Alright, on this problem we're going to translate the following phrases into algebraic expressions. 8 less than 19. Remember, with the words less than, you have to reverse the order. So this would be 19 minus 8. The next one is the product of 7 and y. So product means multiply. So you could put 7y as your answer, or you could put 7 times y like that. You could put a dot in between. Get away from using x though as your multiplication, because now x is a variable. So use either the little dot or use just 7y is really preferred, but I would take either of these for full credit. Okay, on the third one, the quotient of y and 3, I really like using the fraction bar for division. It's cleaner, it's neater, it looks so much nicer, and this way right here, although not wrong, is very elementary. So I really like this way better. Now this says 5 times the sum of this, so I need to write the sum of x and y, and then I want 5 times that. There you go. Alright, on these two problems we are determining whether the given value is a solution of the equation. So on this first one right here, I am going to substitute 8 in for x, and I'm going to see if it gives me a true statement. So on part A, I'm going to put 8 plus 13. Does that equal 21? 8 plus 13 is 21, and 21 equals 21. So on part A, I would say yes. On part B, I am going to put 34 in for x, and 34 plus 13 is 47, which does not equal 21, so I would say no for this one. So our answer is yes to A and no to B. So let's take a look at this next one. On the first one, I'm going to let k equal 1. I'm going to put 1 in everywhere I see k and see if it makes a true statement. Alright, 18 times 1 is 18. 18 minus 3 is 15. 12 times 1 is 12. 12 plus 33 is 45. Those are not equal to each other, so on part A, I would say no. On part B, I'm going to let k equal 6. So I've got 18 times 6 minus 3. Does that equal 12 times 6 plus 33? And I'm going to grab my calculator for this, and here's what I'm typing into my calculator. I'm typing in 18 times 6 minus 3, and I get 105 on the left. Now I'm typing in 12 times 6 plus 33, and I get 105 there. So those are equal to each other, so in part B, I would say yes. Alright, so on these, I want to solve the equations. It is so important that you show good work. So what I want to see on this first one right here is I want to see that you can write minus 62 on both sides. That's the work that I want shown. So I've got S is equal to, now if you want to grab your calculator at this point, that's fine. You can type in 95 minus 62 if you want. Okay, but I want you to still show this step right here and this right here. Those are the two things that I will be grading. Alright, so on the top right, we'll call this one number 2. I've got 17 is equal to y plus 6. So the work that I want to see is subtract 6 from both sides. This creates 0, so I've got just a plain old y on the right. 17 minus 6 is 11. And that's a perfectly good answer. You can leave your answer like that. You don't always have to have your variable on the left. Alright, so on this third one down here, I've got v minus 7. So you want to do the opposite. So I want to add 7. So I've got v is equal to 42. And on the fourth one, I've got q minus 72, so I want to add 72 to both sides. So 18 plus 72 is 90. Alright, so if I want to find all the factors, factors are numbers who can go into that number evenly, without any leftover, without any decimals. So my factors of 36, I always start out at 1. And what times 1 gives you 36? 36. So then I count up from 1. And will 2 go into 36 evenly? Yes, it will. And what times 2 gives you 36? 18. The next number up is 3, and 3 does go in. 3 times 12. Next number is 4. 4 goes in. 4 times 9. 5 does not, but 6 does, and it's 6 times 6. You don't have to list 6 twice. So these are all the factors of 36. 1, 2, 3, 4, 6, 9, 12, 18, and 36. Now let's do the same thing for 60. So I've got 1 and 60. I've got 2 and 30. I've got 3 and 20. I've got 4 and 15. 5 and 12. 6 and 10. 7 won't go in. 8 doesn't go in evenly. 9 doesn't go in evenly. 10 does, but we already have it listed, so that means we're finished. We have listed every single factor of 60. Okay, to find the prime factorization, I like to do the factor trees. So I think of a prime number that will go into 115. And that number that's right on the top of my head is 5. So I've got 5 times 23. And both of those are prime, so I can circle them, and now I have found the prime factorization of 115. Alright, so 252. The number that comes to the top of my mind is 2. So 252 divided by 2 is 126. I'm going to circle 2 because it's prime. Now I'm going to do a tree for 126 because it's even. I know at least a 2 will go in there. 2 and 63. For 63, what comes to mind is 7 times 9. 7's prime, but 9 is not. And then I've got 3 times 3, and both of those are prime. So the prime factorization of 252 is 2 times 2 times 7 times 3 times 3. Or if you want to write it, least to greatest, it doesn't matter. I don't really care. And I'm going to also use exponents for this. So I've got 2 squared times 3 squared times 7. Okay, so to find the least common multiple for these numbers, I usually just list the numbers. And I usually write my bigger number first. So 12, 24, and whenever I think of these numbers individually, I think of, will 8 go into 12 evenly? Nope. And then my next multiple up from 12 is 24, and will 8 go into 24? Yeah. So there's my LCM for 8 and 12. It's 24. Now again, I'll usually write down on 28 and 40, I'll write down my bigger number. And my multiples of 40 are 40, 80, 120, 160. And I'm not sure of my multiples of 28. Those aren't the kind of thing that I really memorize in life. So I know I've got 28 and 56. So now on my calculator I'm typing in 28 times 3, and I get 84, which is not a multiple of 40. So now I'm going to do 28 times 4. I get 112. Nope. 28 times 5, 140. Nope. Getting closer though, I feel like. 28 times 6, 168. Nope. Well, let's count up. So 200. Let's keep going. So now 28 times 1, 2, 3, 4, 5, 6, 7. I get 196. I'm going to have to keep going. So now 240. So now 28 times 8. 224. 28 times 9. 252. And I know that it has to end in a 0 because the 40 ends in a 0. So 28 times 10, I get 280. We may have found it because the next one after 240 is 280. So there's our LCM for 28 and 40. There we go. Alright, so if I want to simplify opposite of negative 8, which is positive 8. So anytime you have a double negative, they cancel each other out. Same thing goes here. So opposite of negative 12 is positive 12. Alrighty, on this page we're going to use greater than, less than, or equal to order the following. So let's look at this first one right here. 12 and 30. Which one would you rather have money in your pocket? So let's think of money this time. I'd rather have $30, so that means 30 is greater than 12, or if you read it from left to right, 12 is less than 30. Alright, let's look over here. So I've got negative 9 on the left, and what is the absolute value of negative 9? It's positive 9, and you'd rather have positive 9 in your pocket, so that's why negative 9 is less than 9. The next one, number 3, down here. So see how that negative sign is on the outside of the absolute value bars? The left side is going to be negative 3. The right side is also negative 3. So those are equal to each other. And the last one. Which one would you rather be overdrawn in your checking account? We'd rather not be overdrawn at all, but we'd rather be negative 4 overdrawn rather than negative 16 overdrawn. Okay, in the last page, we are translating each phrase into an expression with integers. And so, to translate this first one, the opposite of 11, what is the opposite of 11? It's just negative 11. What is the opposite of negative 4? It is positive 4. Now, in this next one, they're not asking us for the opposite. They're just saying write negative 9 down. So, there you go. And then the last one, 8 minus negative 2. You would write 8 minus, and notice how I put negative 2 inside parentheses. That's because it just looks cleaner than that. So, using the parentheses just makes it look a little bit prettier than whenever you don't use parentheses, because having those two minus signs right next to each other just looks a little messy and sloppy. So that's why this would work. If you gave me this right here on a test, I would accept it, and I wouldn't even get mad at you at all. I wouldn't take off any points or anything, but I'm just letting you know this one right here looks cleaner. Alright, so that's it for the quiz. Hope you guys did well, and we'll see you soon.